Welcome back to part 2 of Module 13, Lesson 4, where we're continuing our study of dilations. We left off completing Example 1, and now it's going to be your turn to complete Extra Example 1 on your own, where we have quadrilateral LMNO, and it tells you what its vertices are and tells you that the scale factor is going to be 2.5. Your job is going to be to graph that one on this coordinate plane. We will graph the new quadrilateral on this coordinate plane after it has been scaled. Go ahead, pause the video, work on that at this time. Alright, I went ahead and laid the foundation for my problem where I've listed the coordinates of each of the pre-image points, and then I showed in here where I multiplied each one of those coordinates by 2.5 because we had a scale factor of 2.5. From here, let's go ahead and pull it on out. So 2 times 4 is going to be 8, and then another half is going to be 10, so that one is going to give me a point that's going to be a negative 10 and a positive 10 for its new coordinate. The next values is going to be right here. It's going to be a 10 again, and then that next one's going to be a 5 for that coordinate, because 2.5 times 2 is equal to 5. 2.5 times 6, well, that's going to be 12, plus 3 is going to be a 15, and a 2.5 times 4, that's going to be 8, plus 2 is going to be a 10, and then our last set is going to be 2.5 times a negative 2 is going to give me a negative 5, and a 2.5 times 6, that's going to give me that 15 again that we found earlier. Now I do also need to list these as being L prime, M prime, N prime, and O prime. And that's going to be the coordinates that I'm going to graph on my coordinate plane. So let's jump back over to our coordinate plane, which is right here. And first point I need to do is a negative 10, 10. So I'm going to grab and make my color, actually, black will work. Black's fine. So I'm going to go start it here. Superman runs before he flies, a negative 10, and a positive 10, and that's going to be my first point. My next point is going to be a 10, 5, so we're going to take and jump back over here, add a point, and we're going to start at the origin, go to 10 and 5, which is right there. My next point is going to be at 15, 10, add another point here, start your origin, run it out to 15 and up to 10, which is going to be right there. And then finally, my last point is going to be at negative 5, 15, add a point, start at the origin, go to negative 5, and all the way up to 15. From here, we want to do it in the order that they gave it to us, which was L, M, N, O, and see if that'll mark it right that way. So I'm going to start at L prime, go to M prime, N prime, O prime, and then back to L prime again. Let's see if it gives us correct. That marked it wrong, it's not wrong. Somehow, for some reason, these graphs don't like it when we do this, so everything here should be good. I did create another parallelogram. Everything looks good here to me. Following up on that comment, let's just see what they put. That is my answer. This is their answer, my answer, their answer. You can see it's the same. Oh, no, theirs is actually 1 point off. So, I see what happened. I didn't make it to 15. Mine ended up being 14 instead. I guess I just slipped on it. Okay, we've made something bigger. Now let's make it smaller. We have triangle JKL, and it gives us the points of each one of those, and they want us to take and dilate it with a scale factor of 1/2. 1/2 is smaller than 1. That means our new figure or image is going to be smaller than the pre-image was. To work this one, we're going to do it just like we did the last one, only instead of multiplying by 2 or 2.5, we're multiplying each of the x and y values by 1/2. Which is a scale factor. So when we do that, we're going to take and let's see if we can do 1/2. I'm going to try it as a decimal version here. 1/2 times 3 is going to be 1.5, comma space. 1/2 times 8 is going to be 4. Accept and check. Alright, I plugged all of my 1/2 values in. I'm going to hit check. It checked it. It did like the decimal value. That makes it nice. From here, all we have to do is take and plot those new points on the coordinate plane. So you can see our coordinate plane is broken down into half sections. Each one of the squares represents 1/2, which is going to be nice. So the values we have, they said 3/2. That's also known as 1.5. So 3/2, 4. Let's go ahead and lay out our point. We're going to run out to 3/2. We're going to run up to 4. That's going to be our J prime. Our K prime is going to be 5, 3. So we're going to take and go 5 and 3. And our L prime is going to be at 0.41. So here we are at 4 and 1. We're going to take and something. I did that one wrong. 3/2, that's 1.5. So that one should be right there, 1.5 over 4. That looks better. Now all I have to do is connect my dots, just like that. And let's check the answer. And once again, it's telling me it's going to be incorrect. It just doesn't like my work. But let's see what it says the real answer is. So check it. We're going to take and say their answer, show answer, my answer, show answer, my answer. You can see this time I did the same exact thing they did. For some reason it doesn't mark us right when we get it right on these problems. Once again, it is your turn to do extra example number 2. Go ahead and pause the video and dilate this quadrilateral by a factor of 1/3. It looks like, yep, every single one of their numbers is divisible by 3, so this should be pretty easy to do. Okay, I went ahead and did the foundational work for you here. I listed each of my coordinates, and I took each piece of that coordinate and multiplied by 1/3. From here, I'm actually going to do the math on it. So 1/3 times -3, 1/3 of -3 is going to be a -1. 1/3 of 3 is going to be a +1. That's our F prime. Our G prime, 1/3 of 3 is 1, 1/3 of 3 is 1. Our H prime, 1/3 of 6, that's going to end up being a 2. 1/3 of -3, that's going to be a -1. And our I prime, 1/3 of -3 is -1. 1/3 of -3 is -1 again. Now all we have to do is plot those points and connect the dots. So I'm going to jump back over here. I'm going to zoom out some. Where let's pick a pretty color like, I don't know, green. I like green. And we'll start off with our first point, which took place at point -1, 1. So I have -1, 1 right there. My next point is at 1, 1. So I'm going to add another point. It's going to go 1, 1 right there. My next point is going to be at 2, -1. So I'm going to go 2, -1. And my last point is going to be at -1, -1, which is right here. From here, we're just going to connect the dots. 1, 2, 3, 4, and back to 5. Let's see if it's going to check that one right. Once again, it claims that I am wrong, but let's see what they say. They're going to show their answer, show my answer, show their answer, show my answer. I got the same exact thing they did. My answer's right. Finally, we're on to example 3, which wants us to use coordinate notation to describe dilations. And you can see we've got the original or pre-image is a blue triangle, and the image or new image is going to be our green triangle. So what's going on in here? Let's see how they want us to handle it. It says compare the coordinates of each pre-image and their the image. So I'm going to go ahead and do that and then come back to you. Actually, I just cheated and made the computer tell us to do it because, you know, I've been making 13 modules worth of lessons for y'all. Anyhow, so here we've got our pre-image numbers, and here we have our image numbers. What do you notice between them? What do you see? I had a -2 that became a -1. I had a 4 that became a 2. A 4 became a 2. A -2 became a -1. And these two -4s became -2s. So what did they do to the pre-image to get to the image? They divided each one of those numbers by 2, also known as multiplying it by 1/2. So the coordinates of the image are half the coordinates of the pre-image. Therefore, your scale factor is going to be 1/2, and the dilation is going to be a reduction, with the coordinate notation becoming 1/2 x, 1/2 y. Check our answers. Everything checks. One more problem for us to do. You guys stop the video, work extra example number 3 on your own, put in your answers, and see if it tells you you're right. Now, in answering this question, I'm only going to focus on 1 point, because if it works for 1 point, it's going to work for the other 2 points in this triangle. So, I'm going to start off with point X, and X has the coordinates that you can see here. Let's make that blue, since we're dealing with the blue triangle first. So, X has got the coordinates of run 3, rise 1, 2, 3, 4, 5, 6. So, it has coordinates of 3, 6, and we need to figure out how we're going to get to x prime, and x prime has got the coordinates of 2, 1, 2, 3, 4, 2, 4. So what could I multiply 3 by to get to 2? What could I multiply 6 by to get to 4? And the answer is going to be 2/3, because 2/3 times 3, whoops, when you do that math, you'd simplify and multiply, and that would end up giving you 2. If you did 2/3 times 6, once again, you simplify and multiply, and you're going to get 4/1, otherwise known as 4. So the scale factor we're going to use is 2/3, and now all we have to do is put that into a formula here. So I'm going to do actually I need parentheses first, so let me delete that. Do parentheses. We're going to do a scale factor of 2/3 times our y value. Put a comma in a space, and then we're going to do 2/3 times our x value. Oops, nope, that x goes on the end. Our x value right here. We're going to hit accept and check our answers, and for some reason it did not like it. Oh, well, dummy, I put my x and my y in the wrong spot. Let's turn that around. That's what happens when Mr. Reese talks instead of thinks. So we're going to change that to an X, and we're going to take and change this to a Y. Now we're going to accept it, and we have happy sounds. That's it for this lesson. Get busy working on your homework. Bring me any questions you have in class tomorrow.